Assalamualaikum warahmatullahi wabarakatuh. Today, our group want to present about assessment 3 video presentation for assignment calculus 1. The topic is about application of differentiation related rates. So, moving to next slide.
So there are several topics in this video that we are going to discuss and explain in this video. The first one is descriptive title. The second one is title of selected topic, introduction of the topic, problem statement, problem solution, conclusion, and reference. So this is our group, which consists 4 members, including me, Syahmi bin Faizol, Hazim Zafran bin Zulkifli, Muhammad Anwar bin Hafizul, and the last one is Amir Naufal bin Anizam. So let's jump to our main topic in this video, which is application of differentiation related rule. Introduction. Related rates are a branch of mathematics that involve the use of differentials to solve problems involving interacting variable quantities. In related rates problem, you are given the rate of change of one quantity and are asked to find the rate of change of another related quantity. We use relative quantities to solve problems involving rates of change in real-world conditions. This problem typically requires finding the rate of change of one variable in relation to another when two variables associate an equation with each other. By using related rates, we can calculate how quickly one variable changes in relation to another. This is useful in many fields such as physics, engineering, and economics.
For the next part is we're going to know what is our problem statement in this question. This question given a figure that has a wall and a floor, and that has a length which is 30 meters. The question is 30 meter ladder is resting against a wall as shown above. If the top of ladder is being pushed down toward the floor at rate 1/4 meter per second, how fast is the angle between the bottom of the ladder and the floor changing differential of the theta and differential of the time when the angle is pi/6 radian.
The second problem that we will discuss in this video is the area A cm² of triangle is given as A equal to 1/2 x square. If the area of triangle is decreasing at rate of 5 cm per second, find the rate of change of the side x when the area of the triangle is 162 cm².
For a problem solution in question 1, for the first step, we're gonna know what information given on the question. We get information from the question is dy/dt over 1/4 meter per second, and the question need us to find d theta over dt. For the first step, we must create a chain rule to find d theta over dt. d theta over dt equals to d theta over dy times dy over dt. After we use a chain rule, we must find d theta over dy. For another step, we must choose a correct equation from the trigonometric function. We use a sin theta over y/13. We use a sin theta because sin theta has a y in the equation. And after this, we use y as subject matter to solve the equation. We get y equals to 13 sin theta. For the next step, we must differentiate dy over d theta in respect of y. From the result of dy over d theta, we got 13 cos theta. For step number 3, we must search d theta over dy. The result from we search d theta over dy, we got 1/13 cos theta. We got 1/cos theta from we divide 1 over dy over d theta. And next step is step number 4. We must substitute d theta over dy, which is 1 over 13 cos, and dy over dt, which is negative 1 over 4 meter per second, into the equation chain rule that we used back then. From we substitute from this equation, we got negative 1 over 52 cos theta, and we must substitute theta with the radian that given in the question, which is theta over 6. After we substitute this information from the question, we got the answer, which is 0.022 radian per second.
For the second problem, first of all, we need to take out all the information that be given in the question. For example, we have dA over dt equal to negative 5 cm square per second, A equal to 1 over 2x square, and the area given is 162 cm square. For the first step, we need to create a chain rule to find dx over dt. So dx over dt equal to dx over dA multiplied by dA over dt. For the second step, we need to differentiate for the area of the triangle, which also the same as dA over dx. So dA over dx equal to 1 over 2, and we differentiate the x square, we get 1 over 2x, and the end product is x. For the third step, we need to search for dA over dx. So 1 divide by dA over dx, which we get from the previous steps, and then we get 1 over x, which is dx over dA. For the fourth step, search for x. To search for x, we need to combine both of the area that be given in the question, which is a equal to 1 over 2x square and a equal to 162 cm square. So at the end, we get x equal to 18. For step number 5, we will substitute x into dx over dA. So 1 over x, we substitute the x and we get 1 over 18. For the last step, we will substitute all the information that we'll get into the first equation, which is dx over dt equal to dx over dA multiplied by dA over dt. So we get dx over dt equal to 1 over 18 multiplied by negative 5. So we get negative 5 over 18, and the answer is negative 0.28.
Okay, last but not least, it is about a conclusion. So, if we know how to the variable are related, and we know how to properly apply the chain rule, using the reversible method or not, knowing that, we can address the question. It is not just about finding the right formula and making the right inference. It is about difference between the word to get a solid answer. For the reference, there are 3 references that we refer for doing this calculation. Okay, there are 2 from the website, which is calculus y related rates and related rate definition, application, and examples that we search from the internet. And the last reference is from topical practice that made from Sir Teo Yongkin. Okay, that's all from our group. So thank you so much for paying attention. Bye.